variation.
A variation, thank you. A variation of that, guys. We did that, so that's going to save me a little time on that. Now, one that looks interesting to me would be, part B here. I see on your handout this one. There's a marker here. 2x subtract 3 over x plus 4. Now this one is going to be nice. This one, I think, the advantage is going to answer some of those questions you may have about all this we're doing. And they're asked us to find the inverse. I want you to do this. Just about right like that. Inverse function, f superscript -1 of x. Only 2 steps to find it. First, is it a one-to-one function? I did not list ordered pairs for you. All you see is the raw form of the function. Does anyone think that maybe this is not one-to-one and can show me with maybe ordered pairs it's not? If it's not, we move on to say this thing has no inverse. Can anyone come up with maybe an example of ordered pairs that would show me, Professor, it's not one-to-one, so forget it? Or is it one-to-one? What do you guys think? Okay, close. Beautiful. Okay, now you know how I am. You know how I teach. I try to get these topics to relate. And I'm sort of close out this shortly here. Is that a rational function? Were we doing rational functions yesterday? That's the connection. We were doing this yesterday. What we were doing yesterday, we were graphing it. Asymptotes, crossover points, all that business. And we got through it. It was madness, but we finally got through it, right? So I'm going to first sketch this. And what are they doing today, Adrian? They're asking me to do what? Now find that function's inverse. Where yesterday, with all that business of asymptotes and so forth, we thought, like this, Professor. I just saw this yesterday. I just barely got my mind wrapped around this. And now what are they doing today? They're saying, now find that function's inverse. I love this problem. So first, since you're going to have a quiz, it's not on this quiz tonight, eventually you're going to have an exam coming up. Probably a quiz also next Wednesday with a beautiful rational function to sketch for me. So I'm going to do it right now. I'm going to quickly sketch it with your help. I'm not going to go through all the detail I did, I guess, yesterday. But with your help, I'd like to see what this function looks like. And then we're supposed to find the inverse. This is beautiful. What's going to happen? Connecting math. Here we go. Okay, guys, I'll need your help. Now, I had a student, Stevenson, I think it was. Thank you. He read to me. He read to the class test. You remember those steps? Now, I'm not going to ask him to read through those steps again. We're going to just jump into it and try to get the graph done. But we know the steps to follow. Guys, first, can you tell me what the domain is on the original function? They did not list it for me, but can you tell me what it is on the original function? X cannot be -4. Which should eventually be the range of the inverse. This is the way it works. Now, I've got some clever students in class. I haven't cracked this yet. Oscar, in the back of there, a mathematician back there. How about the range of the original? I'm not trying to put you on the spot. The range. Wonder what the range of that original function might be. The domain was easily seen as x cannot be -4. Oscar, do you have any ideas about what the range might be?
Would be, it's
so it can't be whatever the result is here, so it's negative.
I agree with that.
So,
Listen, no, I'm just not putting you on the spot, just think about it.
Can't be.
If I were a student, I'd say, I don't think, Professor, I can't see directly right now. That's why I'm gonna graph it.
Can't be right.
Now, I see hands went up, said, Professor, no, I think I may be able to see. As a student, I don't think I could, but I'm gonna graph it anyway. Nima, what you got in mind? For the range.
Yes, if I'm not mistaken, for less than 4, for minus, the range goes to positive infinity, and for more than 4, the range goes to negative infinity.
Whoa. Okay. That's what I follow you.
If I'm not mistaken, that's right. Yes.
I was correct. I thought what that first statement you made, absolutely. I need a graph. I need a picture.
Is there a horizontal?
Before I jump in and try to get that on my, this is me, before I identify that. Yes.
Is there a horizontal aspect?
And there we go. That relates back to yesterday. That's why I brought this in. Now, let's do it, guys. We'll do it quickly. I'm gonna leave this open right now. We'll come back and answer this shortly. So we'll graph it first. Let me graph it right quickly, guys. If I asked you from yesterday, where is the x-intercept? Which would help locate it. You're supposed to set the function equal to 0. Or the y equal to 0. We did this. Cross multiply, guys, will give you this. Cross multiplication or solve that equation. And if I have no mistake, it's 3 halves. 1 and 1 half. So I now know, and we'll go to it right now, that when I mark this, my x-intercept is right there, at 1 and 1 half. Halfway between 1 and 2. Y-intercept. We know how to find it. We did this yesterday. You go back and replace x by 0. In other words, you find f of 0. Guys, if I do that, I'll actually show it. This is so nicely closed down. You're going to end up with -3/4 if I have no mistake. So down here, at -3/4, you mark this as -1 for a reference. You put -3/4 close to a -1. Right there. That's my y-intercept. That true? Now, can anyone tell me, does this function have a vertical asymptote? A vertical. And I think when he read that to us yesterday, guys, to find the vertical asymptote, you do what to find the location of it? Who remembers it? Yeah, he said that denominator equal to 0. If I set my denominator equal to 0, guys, and solve it, now this is vertical asymptote. And if you look at your handout, it says to find where it is, you take that denominator and solve it. If I'm correct, it's out here at -4. I think, even though you're a little tired today, I think you're going to appreciate this. Wait till you see what's going to happen. This is my vertical asymptote. I have my intercept, I have my vertical asymptote. Is there a horizontal asymptote? Well, yesterday in my discussion, I said without going through that business of calculus, that one over x business, if your degrees match up. The degree here on top then should be a 1. What's my degree highest exponent on the bottom? They match up. That's the easiest case ever. Your horizontal asymptote should be the ratio of these coefficients. 2/1. So my horizontal, in no time, will be y is equal to, not 1, y is equal to 2. So let's go to 2. I'll mark it right there and show real quickly. I'll put it like this, guys, so you can see it. This is my horizontal. I'll tell you ahead of time, there is no crossover point on this one, just to save you a little time. So we got the horizontal, we got the vertical, we have the intercepts. Am I leaving out anything else in the details that we did yesterday? Vertical asymptote, horizontal asymptote, crossover point, I'm telling you ahead of time, there's no crossover point on this one. intercept, is that all I need, I think? Help me out. Now, how many pieces to this graph will there be? Well, there's only one vertical asymptote. It's here. So there's something happening to the left, and there's something happening to the right. I hate to erase that, but I want to really show you something. Leave it like this. Something's happening to the left, something's happening to the right. Guys, to the right, let's get the right done first. To the right of -4. I've got to pick up these 2 points. I don't think we have much choice. I don't think we have much choice. To follow the asymptotes. Over on the right, there's another little piece over to the right of -4 over here. Guys, when you plot in the block points, like I did yesterday, I think you're going to find it to be here. The other piece. There's the graph. If I made no mistake, that's the graph of Jonathan, that's the graph of this. With yesterday's connection. Now, by the way, would that pass the horizontal line test? If I pass the horizontal line, would it pass the horizontal line test? So this thing does have an inverse. Now they want you to find the inverse of this crazy thing. Now though, let me get back to this. Nima,
Yes.
you helped me out. You helped me out yesterday also. Can you now tell the class this had a graph? We got the domain. We said x cannot be equal to, I almost covered that here, -4. Can you tell the class now what the range would be since I now have a graph?
Yes. When x approaches to -4 from the left, the range goes to positive infinity.
Okay, tell me in interval notation. You're describing it perfectly. But just tell me in interval notation, what's the range? Your inscription's correct, but what is interval notation? Negative infinity.
Negative infinity
Up to,
to 2.
where was my horizontal? 2?
2, yes.
Okay, then union.
Union 2 to positive infinity.
Perfect. Perfect. There's your range. Based on that graph, think of that graph is. I don't know how many students would have thought that that was the range, just by merely looking at this. So I think the graph helped. Now, Jonathan, close this down, make connections here. I've got all that business staring at me. That's fine, Ramsey, but they're asking to find the inverse of that mess. They now want the inverse of this. Now we'll go up on the side here and try to find the inverse. And that inverse means, here we go. Step 1, only 2 steps. Step 1 to find this is to interchange the coordinates. In other words, go back to this function, interchange. In other words, you're going to make this now look like this. X is equal to 2y subtract 3 over y plus 4. Oh, this is going to be beautiful. To close down, this is going to be beautiful. Yeah. And what's step 2 of the 2-step plan? First you interchange. Step 2 is solve for y. Thank you. You got to solve for y. There's only 2 steps. Hey guys, here's your algebra skills are needed. I'm going to cross multiply. You guys can do it some other way, but I'm going to cross multiply. I'm going to multiply these 2 together. I think cross multiplication is so quick. And these 2. One direction says x times y plus 4, and in the other direction, just merely 1 times 2y subtract 3. That looks like my cross multiplication. Now I got to solve for y. Distributive property, x, y plus 4x is equal to 2y subtract 3. We're back in middle school. They want me to solve for y, because so much of it, though, we are back in middle school. How are you going to solve for y? Because I see 2 terms containing y. Usually just 1 term. I got 2 here. What am I going to do? Yes?
Can I see the equation?
Do it again.
Can I see the equation?
Okay, what about the equation?
Like the next step.
In the next step here.
Yeah.
Tell me what to do.
xy minus 2y.
There you go. There you go. That's what I wanted to hear. He's dead. He's telling me. It's right there, good. He said, Professor, get those terms together. They contain the y. Move everything else over.
Yeah.
So if I move over that 4x, let's see, do I have a 4x here? Where am I? Yeah. Let's make that what? Negative 4x minus 3. Guys, do I have them now separated? Now, why move those terms together? Why do that? Yeah, well, factor out the y. I'm trying to solve the y. Guys, last step. Divide by this, divide by this. These cancel. There's y by itself. In other words, this is your inverse. Been waiting for this problem. There's the inverse of this. I'm not going to graph it. By the way, it came out to be another rational function. I could actually graph it also. Adrian, help me out here. Tell the class. Here's the inverse. Can you tell the class right quickly what must I express for the domain?
It is everything except for 2.
X cannot be 2. Hang on now. Or if we'll put in interval notation, here we go.
So
Here's
negative
having, negative infinity up to what, 2?
2, and then union, and then 2 to positive infinity.
This guy's got it. Adrian, that's the domain. I agree with you 100%. That's the domain on this answer. Does that now correspond with the range that someone gave me earlier? I can find it here somewhere. Where was the range, or did we actually list the range here somewhere?
It's there in red.
Right there. But is that the same thing? So is the domain of this the same as the range of that? Okay, now the last part is the range should correspond with what? The domain. And we've already said the domain was, I think back here somewhere, x could not be equal to, what was it? Negative 4, and that would be expressed as an interval notation to which, what is it, negative infinity up to negative 4, union, negative 4 through infinity. Is that true? So those domain ranges will match up. Now I know we're getting close to that quiz. Here's the part I was happy to see. This is the part I was hoping when I created this worksheet. I thought, whoa, I got to put something on there that relates to yesterday. And this does relate to yesterday. This one's done. By the way, guys, I'm not going to grab this one. Now, can someone tell me? Here it goes. This is the nice thing about this. This function's inverse. Barbara, tell the class right quickly, where is the vertical asymptote located if I were to graph the inverse? 2. You said the denominator equals 0 and you get 2. That's the vertical asymptote. Where was the horizontal back on the original? 2. They interchanged. Another one here. Let's see if I call some students here. Some of the students in the back. Maybe. Let's try one here first. Anyone look at this? Here's the inverse. And tell me right quickly, what is the y-intercept if I were to graph this? Replacing x by 0. What's the y-intercept on this right here if I should do it? Is it negative 3 over a negative 2? If you replace the x's with 0, which is what? Positive 3 halves? Now that's the y-intercept, 3 halves. That was the what over here? The x-intercept. They interchange. Does that help now see the relationship between the two functions? Everything's interchanging. The x-intercept over there becomes the y there. The vertical asymptote there becomes the horizontal there. Everything's interchanging. on this. So I thought it'd be a nice problem to bring in, I brought it in. I brought it in and it works out. Now, what you've been waiting for. I saw students, when I was doing all this, I saw students getting a little nervous. They're saying, Professor, I want that quiz. I'm not doing that. I mean, you do inverses all day, Professor, and domain and range. Nice. I want to see that quiz.